Okay, so we'll start on this version control. Earlier version control was that piece of software which had a lot of kind of stealth effect to it. And not much people would reveal much about how this version control works and things like that. And it was kind of dominated by a few organizations, and one of the most important, I don't know if you've heard of this company called Rational Rose, and they are the ones who probably made this more popular. And there were various organizations who came with their own version control, and these are all branded products, costed products. And as we stand in 2014 today, none of these are ever in prominence. They are kind of got sidelined so badly by these open source tools. Today, actually, version control is literally run by these open source version control tools. Though there are some still in place, but even if they are off the way to be replaced than anything else. Okay, so version control or revision control, also known as source control, is the process of managing and tracking changes to anything. People think revision control is, or the version control is only for code. It is for documents, it is for code, and more importantly, from the perspective of DevOps, it is actually configuration files. Okay, so this is where it becomes the most important, and tools like Puppet and so use version control to manage configuration files, or some form of version control is always there in an organization which runs automation, right? Wherever there's automation, there is some kind of open source, version control tool to manage your configuration part, apart from code management. Okay, like now in the places where I worked, you had a complete set of tools. You had one complete instance for code management that went through a different cycle of that had a completely different architecture with higher levels of redundancy and things like that. But we also had a completely different version control for configuration files. When I say configuration files, anything that is required for your infrastructure automation, all of them are kept. So it could be a configuration file, it could be even a spec file of your RPM, right? So everything is kept in this, and it is ideally we will have two different bases, one for your code, one for your configuration management. So configuration management will will ideally have a separate tool, will have a separate instance of version control. Okay, and as we see today, Git is becoming the most popular of them all, but others are still in existence. It is a repository of files. It helps large projects from going out of control by letting individual programmers, writers, or project managers undertake a project from various angles without getting in each other's way and without damaging that can't be undone. Okay, and the most popular. So we actually had CVS, right? That was the most popular of the open source, and it was a bit complicated, and that got branched out into SVN. SVN is what is used quite popularly in India, and SVN then got it got replaced more like with the Git. Git became more popular. There are other tools like Purpose and Bitkeeper and all that. They are popular, but I eventually see Git replacing all of this, and SVN will also continue to be there. But there's a good chance that Git may replace everything, because GitHub today is becoming the standard way of managing all your codes, right? So this is a good picture of how this entire version control handles. We have multiple developers. They all dump the code into SVN, and then the SVN will have different, or the version control will have different branches, one for staging, one for production, and then and your Jenkins and other tools actually pull it out from here and then do the package management. So you kind of understand how this now. I think the cycle makes it a little more better, right? To understand, because they are pulling out from these areas to go into the staging and to the live, and this Jenkins would then take care of that part as such. So why version control? I think we know it. It is very important for due diligence. It is essential for any form of distributed collaborative development. Okay, so you know, it should not be that asking why do you want. We can't even think of an environment when you're writing a single piece of code why there is no version control, right? It's like that. I think we had a question, Ramdas. Are we going to have some demos on Jenkins? Yes, Ramdas. We will have some demos on that as well. We will install that. Okay. Yeah, I'm not sure whether we'll be doing it in this class, but yeah, the next class is going to be all about all these labs that we want to kind of do. So in any large organization where there are many developers, okay, it's the same thing, and every change made to the source must be tracked, who made the change and why the change, why they made the change, etc. Such. Okay. So two most widely used, SVN, Subversion as it is called, founded by Collabora.net. Currently it is under Apache. And then HN employs concept of automatic operation that prevents corruption of database. And there are various technologies that are built into it. And the Git, actually Git was created to manage your Linux kernel development. Okay, is a distributed version control system designed by the same guy, the guy who developed the Linux kernel, Linus Torvalds. So Git supports rapid branching and merging, includes specific tools for visualization and navigation, and a full history tree which can be viewed offline. It is distributed and uses peer-to-peer model as the way. Probably it's the peer-to-peer model of Git which appeals to a lot of people than anything else, and yeah, it's kind of becoming the de facto standard for version control. Okay, so this is a centralized form of development. This is the ideal way which you will have in any organization, where be it your source code or your configuration management system. Okay, so you will have your working copies, your devs here, and then updating to a central SVN. Whereas, so GitHub is I mean, it's actually built on Git for sure. GitHub is the public source for all these whoever hosts their own code. Okay, and that's primarily for public distribution, and they have a different architecture. We now follow that in an enterprise as such. Okay, so this whole life cycle of a version control. So you know, we start with a commit, and that gets updated, make changes, fix problems. So the cycle goes on and on. Okay, so see, understand this. When you're building a version control, it's one of the most important part of your organization, because that's where your entire code sits, right? So the level of fault tolerance and high availability which are normally built into a version control system is very, very high, even higher than sometimes I see in your databases itself, right? Your database itself, the database, I mean, it is as much important today to an organization as much as to a bank holding its account information. Okay, it is such a level of HA and the fault tolerance which are built into these particular infrastructures. Because once you lose this, right, your organization loses your IP. So they're very careful about this SVN. So that's why earlier all these rational rows and all these organizations kind of flourished, because their tools were great, but equally were the complexities of it. And then we did not require so much of complexities which were built into those tools. And that's why tools like Gits and SVN all came into the market. Okay, so how do we install an SVN? For SVN to work, Apache must be installed and running. Okay, so everything, as I said, all these days everything goes through the normal Apache way of HTTP way of doing things. So we create a config file in the root, enable the required module, set up the authentication, and configure your repository. So we will we can do either an SVN or a Git based on that what you would like to choose from. So Git is the preferred way, but if you want to use SVN, we will as well as do that. Okay, so as with your Apache, you have some modules directly related with SVN. So we need to unhash them and add the following this into your base authentication and Apache and point Apache to where your actual repository is. So this way you are getting your authentication in place as well as your path to where your repos are sitting in for your files. And creating your authentication. So today, I mean, we don't go through this method. We ideally would prefer LDAP integration. Basically, that's what happens most of the time. We go through a simple LDAP authentication to get into those to your SVN system, and you can also integrate LDAP to your Apache, and that's the way the normal. So we won't have multiple users spread out. It's all SSO based today solutions today as such. Okay, so we will also do a demo of that, and Git. It's the same, but as I said, this is more of a peer-to-peer than a centralized form, and Git has caught the people's imagination for whatever the reason. Maybe because of the GitHub. I truly don't know what is the reason, but Git is what is today got into everybody's imagination, and everybody uses Git. So people who were using SVN have all started migrating to Git, and the usage of SVN has come down so dramatically after this guy has the Git has come in. Primarily because people see it as Git as a great tool, because the entire Linux development is handled through this. So there is no reason for us to believe that this is not a great tool. It seems to be an unbelievable tool, and it is so simple, and that's what adds to it. Okay, so configuring Git, very simple. We will definitely be doing Git. So yum install Git, and we just we have a configuration file, add your few configuration information, and then create a bit of a database, and then you're good to go. It is as simple as that. Okay, so setting up SSH into the server with the required change directories and themes if it is required, get your status, and you can also add a little bit of CSS and things like that if you want to use the web way of doing it. Else, we just do through the command line. So I'm sure you must have used the word git clone so many times, right? Pulling down the entire file as such. And we'll do a complete configuration of this. Okay, so so how do we make changes? We'll see how we can edit a file, make some changes in that, and then push it. Right, we'll push it, and then pull it out and see both the changes, and we'll both the original and the changes that we made, both are there, so that we can see how this entire concept. And so for us, what I want to tell you here is we are looking version control tools from the perspective of configuration management rather than code management. I mean, I keep repeating this because that's what actually happens in most organizations. The configuration part, the configuration management, version control is what you ideally maintain, and this is not complicated as your code base version control is, and that's normally handled by a separate team, and they're normally handled by the developers. This is what we are doing it for the configuration and not to maintain your code. Maybe when you write your small code, you may maintain it. So it can, as I've also seen that this configuration can also have your small code base. Now these code bases are not the app code bases, but these are code bases which you do for creating some scripts, sometimes writing an application to pull a log file, to push a log file, parsing log. It's your own thing. It's all related with your the automation, not related with that. So that is why our approach to Git is to manage your configuration, not to manage your code. And that's where many times people get confused on how do you want to utilize and position this, right? And as you see that without a version control, it is very, very difficult for us itself to manage it, isn't it? Okay, so we will definitely be doing a Git demo for sure. Then, okay, so this is where there's the whole new concept of CIs and CDs are coming. How Git with Jenkins. Okay, so once the developer commits a code, then the build is triggered automatically. It is triggered. It is once it commits the code, the Jenkins server monitors that. Then the build is and probably after this is done, there may be one more layer where the complete testing is. You build it, you do a complete testing. That will be a different environment. So Jenkins can coordinate all of these activities. When I say coordinate, you actually need to write codes to do all of these stuff. So you do the build, you push it into the test environment. Now this is where Jenkins cannot do that operation. Okay, it can build and maintain it in the and it is again maintained in the version control. Now to install it onto a dev platform, Jenkins will not do it. You probably need to have a separate tool, which is the application deployment tool that pulls it out from the GitHub and then installs it on your servers, right? And once it is installed there, it will also do whatever the test. It will do all the tests and all that. Okay, and then it can actually let Jenkins know that it is all fine, and if it is fine, then this guy can then release that build into the production tree. Once it is released into the production tree, then the application deployment tool can pull it out and push it into the production environment. Now this whole process is what we call as your CI and CD. Okay, continuous integration, and this is all about your continuous integration. This whole thing is your continuous deployment. Now what we don't find in the open source world is that tool for deployment. It could be anything. Okay, it could be a custom build, and of course there are various tools that you get in the among the brand products to do that. From the background which I come, this was also a completely custom tool that was built. So ideally, what happens is after the build, right? when I say build, it is exactly creating the package. That's what it does. Okay, it creates the package and pushes it into one of those Yum repositories, from which some tool will pull it down to deploy it. Now I can do this with two ways today. Okay, some guys, some organizations keep a completely different application management tool to do it. Other organizations deploy configuration management tool itself to deploy the application, like Puppet. Puppet can also do application deployment as well. So that is why you find that there is no separate tool to deploy applications, because you already have you already have other tools through which you can actually do it. Okay, so I mean, are you getting this big picture? Now this this is probably the DevOps. When we talk about DevOps, people always think about this picture than anything else, right? So the picture is not fully complete, as I said, and you have a repository, a Yum equivalent repository where your code, your build resides, and also a testing framework environment where you need to check what you have done, the status of that, and only then you push it into the production. So there's a little bit of code and an application there to do that complete test automation, right? Yeah, once all that is in place, you've actually built a CI/CD. Okay, so what your Pixie Boots and the configuration management tools is basically using this CI/CD to deploy your applications. Okay, so let me see a question out here. Okay, so that was the question regarding how this whole Jenkins thing fits into this stuff. Now, but this is what we want to achieve, right? Today, all the business guys will come and tell me, hey, we need. I mean, especially in the, I'll give you the example of whatever happens in the present day web and the web or the internet organization. You would want changes happening in minutes and hours. You can actually do this with this. If the developer can finish the code, and normally he can, because these are not complicated algorithms, right? Or whatever we do in this in the web environment, most of the developers, that is, I'm saying the web developers or the web app developers, most of the case, the algorithm which goes into it or the business logic are not very complicated. They can be written in hours compared to writing a C code to do probably a memory management within your system. The code there is so complicated, and that takes a long time because there's a lot of discussion. There is a lot of mathematics getting involved in that. But here it is not the case, right? It's not the case. Just like as an example, let's take an example of my favorite tool, the IRCTC. How long does it take to actually build that? It is a short time, but it goes through a lot of testing because since it's an internet facing, any application which is facing internet, you need to go through a lot of security checks than anything else compared to your logic. But your business logic is less. It's less, and it is not complicated compared to writing your system applications, which are definitely at a higher level of logic compared to these things. So that's why we are able to do this whole process. And I can tell you, this process does not go for softwares like your operating systems and say you want to release or say imagine you're developing a virtualized application, not virtualization software. So core algorithm related development will not go through this cycle. Okay, they go through the traditional cycle, and that approach is ideally not changed. But it's this architecture is mainly focused for internet-related applications, or more appropriately, web applications facing the internet, which which requires immediate changes, because that's what people love. So that's why you want to change it. Okay, so hope you understand, this full picture what I'm trying to give you here, right? Okay, so yeah, so the Jenkins came in a big way. It was Hudson. So the whole problem of so Jenkins is a copy of Hudson, and Hudson was created at Sun. Okay, and there was a big problem with Oracle, as usual, anything with the open source. So Jenkins provides continuous integration services for software development. It's a Java-based application, basically. It's a container. Its container is based on Tomcat and work with various version control systems like SVN, CVS, and Git. So the idea is very simple. If Jenkins has to work, it has to get, it has to be integrated to a version control system. Okay, otherwise there is no point with that. And it started originally as an Hudson. I think it's still there. I don't know what the status of that. And then after Oracle claimed the name, Jenkins was coined. Okay, again, again, as I say, this was more targeted towards your website. So it includes a feature-rich web user interface that provides the ability to trigger builds, customize builds, manage resources, manage plugins, and various other things. So you can deploy it as it is. Some guys create their own modules and then do things what are more associated with their environment. But more or less, it is the standard installation. But the big guys, the big five, will always customize this to their thing compared to an enterprise world, right? Okay, so builds can be started by a commit to a version control system, scheduling via cron-like mechanism, building when other builds have completed, or requested by a specific build URL. Okay, so various ways. There are mechanisms to start the build process. Okay, and you know what build process means. It's creating a package like your RPM or any other format which are respectively used in those environments. We talk so much of RPM because the most used operating system from the Linux side is Red Hat and CentOS, right? Compared to Ubuntu or SUSE. And though one is used primarily in Europe and the other one is primarily used in Africa, whereas Asian America, it's primarily Red Hat and its variants. Okay, so components of a build. Yeah. So we saw that there are various ways to trigger a build, right? Various ways. It could be a commit, it could be a URL, or it could be something, any other process as well. Then you can it communicates through various channels. What is the status of your build? Email, your IM or an IRC. Okay, so once the build is done, it has to be pushed into a version control for that to be utilized by the application deployment framework, right, or the application deployment tools. And then the results are saved and you do the change. So it is during this process, this Jenkins can also be integrated to various other tools. Like after this build is done and saved, from here I can probably integrate it to a test tool. Okay, so what he will trigger through maybe another tool to do that build, to install the build on the test environment, and then start the testing of it. And once all that is successful, I can then release this to the production branch, right? I mean, you should be aware that they keep multiple branches in your version control. Your test, staging, integration, it could be anything, whatever that each organization follows. Okay, so once more the flow. So yeah, the developer commits, triggers a job, Jenkins. So I told you, right, the Jenkins server, they have their test automation and tools, and and he probably puts into the test side of it, sends the result, and he sends a feedback to the tester. If all is fine, the tester can commit the change into the production, or the Jenkins itself can change it into the production, commit into the production branch. Okay, and it's from that point onward, it's for the other tools to do this complete deployment aspect of it. As such. Okay, so hopefully now you're getting that full picture, right, of how the Jenkins server sits in this environment where there is a version control server, there is probably a test automation seat somewhere sitting, and this whole process of building your packaging your source code. Okay, and it's not only source code, and I said this whole process. Okay, I mean, again, I talk so much about it. I do not again specify that we are using all this for your automation, right? And then we are again using Jenkins here, not for the code base. It's for automation of the it's the packaging of the tools that we as DevOps use, not for the code, for the code, right? So we also go through this complete cycle, right? Like imagine, let's take yesterday's. We say we want to add, okay, what do we say? We want to make some changes into one configuration file. So that also you as a developer will commit to this SVN server, then it is packaged by your Jenkins, and then done a test on the test bed, and then pushed it back. Not the code base here, it is configuration files and scripts that go into the automation suite.